In this video, we will solve the moment of inertia of this I section about its center of gravity. So here all the dimensions of the I section is given. So here we have to find out first the CG of this I section. I have already told you how to find out the CG of this I section. So we will divide it into section 1, section 2 and section 3. So for the first section, we'll take the bottom surface as a reference, and here we know that the I section here it is symmetric about y-axis, so its center of gravity will lie in its y-axis. So we have to find out the y coordinate. Y bar equal to a1 y1 plus a2 y2 plus a3 y3 divided by a1 plus a2 plus a3. A1 equal to 80 into 20 mm square. Y1 equal to, I have taken this bottom surface as a reference, y1 equal to 10. A2 equal to, this dimension is let 300 mm. A2 equal to 300 into 15 mm square. Y2 equal to 300 by 2, that is 150, plus 20, that is 170. A3 equal to 100 into 20 mm square. Y3 equal to 20 by 2, that is 10, plus 300 plus 20, that means 330 mm. So we'll put all these values in the formula and find out first y bar. Y bar equal to 80 into 20 into 10 plus 300 into 15 into 170 plus 100 into 20 into 330 divided by 80 into 20 plus 300 into 15 plus 100 into 20. So we'll solve it and find out the y bar of this center of gravity. So let's solve it. So here after solving this, I got y bar as 177.9012 mm, that is from the bottom surface. From here the center of gravity will lie on the y-axis and at a distance 177 point, distance 177.9012 mm from this bottom surface. So we have calculated the CG. Now we will find out the moment of inertia of this I section along x-axis and through its CG. CG is at this point 177.9012 mm. Through this axis we have to find out the moment of inertia. So first we'll calculate the moment of inertia of the first section about its CG. This is a rectangular cross section. So we know that the moment of inertia of a rectangular cross section, its CG will lie at what distance? At its middle, so at 10. At this point its CG will lie. So We know that the moment of inertia of a rectangle along its CG, along its x-axis is, the formula is bhq by 12. So for section 1, I1 moment of inertia about CG equal to bhq by 12, that is equal to 80 into 20 whole cube divided by 12. But in this question we have to calculate the moment of inertia about this line, about the line passing through the center of gravity of this I section. So we have to use parallel axis theorem. So we have to find out the distance between the CG of this section 1 and CG of the whole I section. So we have to calculate this distance first. So what will be this distance? Total distance is from the bottom surface is 177.9012 mm. So here to here it is 10 mm. So this distance is 177.9012 minus 10. So y1 is 177.9012 minus 10, that is 167.9012 mm. So we will use parallel axis theorem. I1 about x-axis equal to I1g, that is this value, plus area of this section. Area is 18 to 20 into square of the distance between two parallel axes, that is 167.9012 square. So we'll put these values and find out the answers. Whole cube by 12 plus 80 into 20 into 167.9012 square. Similarly, we will find out the center of moment of inertia of the second section about its CG. And the second section is this section. After this, the wave. So here the center of gravity will lie at what distance? 150 from its middle, so it will lie at the distance 150. So but from this surface it will lie at a distance what? 150 plus 20, 170 mm. But the center of gravity of this I section is at what distance? 177.9012 mm. So what will be the distance between center of gravity of this section and center of gravity of this whole I section? That is 177.9012 minus 170. So y2 equal to 177.9012 minus 170, that is equal to 7.9012 mm. It is I2z. I2z is bhq by 12, base is 15 into 300 whole cube by 12. 15 into 300 whole cube divided by 12. So we'll put it in the formula and find out using parallel axis theorem. We'll find out I2 about x-axis, that is 15 into 300 whole cube divided by 12 plus area of this section, that is 300 into 15 into distance between two parallel axes whole square, 7.9012 square. Similarly, we will find out I3g, moment of inertia of the third section about its center of gravity. So third section is at what distance? At its middle, so at 10 mm. So we will find out the distance between this axis and this axis. So total distance is 300 plus 20 plus 20, that is 340 mm. So from the bottom surface of reference, the distance is what? 177.9012. So from here to here to the center of gravity of the whole I section, what will be the distance? 300 plus 20 plus 20, 340 minus 177.9012. 340 minus 177.9012. That will be the distance from the center of gravity of this section from the top reference, from the top. But we have to find out the distance between CG and this line. So what will be the distance? We have to subtract 10. So 340 minus 177.9012 minus 10. That will be y3. y3 equal to 340 minus 177.9012 minus 10. That will be y3. And what is I3G? I3G is the moment of inertia of this I section about its CG. That is about at 10 mm from that reference. So I3G is 100 into 20 whole cube. 100 into 20 whole cube divided by 12. So we will find out the moment of inertia of the third section about the center of gravity of this I section. That is, we will use parallel axis theorem again. VHQ by 12 plus area of the third section, that is 100 into 20 into square of the distance between the two parallel axes, that is 330 minus 177.9012 square. Then what will be the moment of inertia of the whole I section about x axis? That will be the summation of I1 x axis plus I2 x axis plus I3 x axis. That will be the answer.